Deep inside every single thing you see, the screen you're looking at, the air you're breathing, and even the cells that make up your body, lies an invisible universe of extraordinary power. Atoms are the fundamental building blocks of all matter. For centuries, scientists believed atoms were tiny, solid spheres that could never be divided, but nuclear physics completely changed that understanding. It revealed that almost all of an atom's mass, and an incredible amount of energy, is concentrated inside an incredibly small central core called the nucleus. To understand just how small it is, imagine an ordinary apple. If you enlarged that apple until it was the size of the Earth, the nucleus inside one of its atoms would still be so tiny it could fit comfortably on a tabletop. Despite its microscopic size, the nucleus contains over 99.9% of the atom's mass. Nuclear physics is the science that unlocks the secrets hidden within this tiny powerhouse. Inside every nucleus, an intense battle is constantly taking place. The nucleus contains protons and neutrons. Protons carry a positive electrical charge, and according to the laws of physics, positive charges naturally repel one another. If that's true, why doesn't every atom instantly explode apart? The answer is the strong nuclear force, the most powerful fundamental force in nature. It acts like an incredibly powerful subatomic glue, binding protons and neutrons tightly together. In fact, it is much stronger than the electromagnetic force, pushing the protons apart. However, this force has one important limitation. It only works over extremely short distances. If a nucleus becomes too large or the balance between protons and neutrons is disturbed, the strong nuclear force can no longer hold everything together. The nucleus becomes unstable and begins to break down naturally. This process is known as radioactive decay, and it forms the foundation of nuclear science. Scientists eventually learned how to release the enormous energy stored inside atomic nuclei through two different processes: nuclear fission and nuclear fusion. Nuclear fission works by splitting apart large, unstable atoms such as uranium-235. When a neutron strikes the nucleus, it becomes unstable and divides into smaller atoms. During this process, a tiny amount of mass disappears. According to Einstein's famous equation, E equals mc squared, that lost mass is converted directly into energy. The reaction also releases additional neutrons, which split nearby atoms and create a self-sustaining chain reaction. This is the principle behind modern nuclear power plants, which generate electricity for millions of homes around the world. Nuclear fusion works in the opposite way. Instead of splitting heavy atoms, it combines light atoms, usually hydrogen, to form helium. Bringing positively charged nuclei close enough together requires temperatures of millions of degrees and enormous pressure. Once they overcome their electrical repulsion, the strong nuclear force binds them together, releasing an even greater amount of energy than fission. Fusion produces very little long-lived radioactive waste and has the potential to provide clean, reliable energy for future generations. Fusion isn't just a scientific theory, it's already happening every second of every day. Our sun is a giant natural fusion reactor. Deep within its core, immense gravity squeezes hydrogen atoms together, producing helium and releasing the light and heat that make life on Earth possible. For decades, scientists have worked to recreate this process on Earth using advanced devices called tokamaks and other experimental fusion reactors. Their goal is often described as building a star in a bottle. If controlled fusion becomes practical, it could provide an almost limitless supply of carbon-free energy using fuel derived from hydrogen isotopes, some of which can be obtained from ordinary seawater. It has the potential to transform the world's energy supply. Nuclear physics is far more than the study of radiation or nuclear power plants. It explains how stars shine, how the elements that make up our bodies were forged inside exploding stars billions of years ago, and how matter itself remains stable. By exploring the smallest structures in the universe, humanity uncovered one of the greatest sources of power ever discovered. The future of science may not depend on looking farther into space, but on looking deeper into the atom. If you're making a YouTube documentary, this version will read as one continuous narration without interrupting the flow with section titles. If you liked this video, remember to like and sub to see a cool animation and support our channel.